Hey everyone, today in this video we'll be discussing a binary tree problem that in that we have to do like an in-order traversal. So basically before that we should understand the meaning of in-order traversal. They are basically the basic three type of traversal in a graph. The in that in-order traversal we will be saying today that means that uh, in order means left, root and right. This pattern should be followed in all of the node of the binary tree. Coming to the example part of it, like you can see we have to follow the left, root, right pattern of during the printing of the node values. So in this graph tree diagram, it's we have to do like in order traversal. So we'll be first moving to the left part. So left part of this is null, so nothing will be printed. Then will come the root, and then we'll go to the right part. So root value will be printed as a 1. Then we will going to the right part. Then again in this node we'll be again following the left, root and the right formula. So coming to the left part, it will 3 will get printed. Then coming to the root part, 2 will get printed, and then coming to the null part, right part, that is null, so nothing will be printed in that. So my in order traversal of this tree will be 1, 3 and then 2. So here you can see it's the same output 1, 3, 2. If it is a null, then null will return. If it's just a one node, then obviously it will be going to the left part, nothing is there. Then it will come to the root, that will be 1, and then it will go to the right, that nothing is there, null is there, so only 1 will get printed. So we'll be seeing coming to the problem statement of how to solve this. Now first we'll be seeing the recursive approach. Since we have to return here the list of integers, so first we'll be declaring the list of integers and we'll name it as a list, and new array list, it will be defined array list. We'll be recursively calling the another function, user defined function in order, and we'll pass the list over there and the root value that is given, and the ultimately will after storing this user defined function will traverse in the whole tree, and it will store the values to the list data structure, and at the end it will return the list value, okay, to its function call. Now it's time to define this user defined function. So my function name is in order. In order, the first is the list of integer. First is the list of integer with the name list. Second is the tree node with the name root, and it will be of a void type. It will not be returning anything, it will be of void type. Then initially it will check if my root is null, okay, if my root is null, so it will be returning nothing, okay. And coming since it is like a left, we will traverse first, then root and then right. So we will just call this same function in order with a root dot left part, and then we will be processing the left and then root. Then we have to with the root part we have to store list dot add the values that the root is containing, root dot value, and finally we have to call the right part in order, and finally we have to call the root dot right part. But here you can see we are passing the two parameter list and tree node. So here list will also come, list and tree node. Here also list should come first, then the root node. Okay, now we'll run and check this node, check this program. Yeah, it's correct, checking for all of its condition. Yeah, it's getting accepted. Okay, so coming to the iterative approach. Now this was the recursive approach. Now if it has been told not to use the recursive approach, then you will be doing with the iterative one. So we'll first clear this. Okay, now for the iterative one, we have to use the stack. Okay, first we will declare what the data type we have to return. What the data type we have to return is the list of integer. We will first define it an array list. Okay, an array list. Okay, then we have to define like a stack, and we will define this tree node so that we are pushing the nodes to it, and stack name st will keep it, then new stack. Okay, and then we'll be calling like a ultimately we have to return the list. Okay, and in between this we have to store all the values to the list. Okay, so we'll call like a day while. Okay, and it will run till it's true, and at some point of time we'll break the loop. Okay, okay, here so here we'll be checking. First we have to process the left, then root, and then right. So whenever we are getting the value, we just push it in the stack. So st dot push. The first job we have to do is whatever elements we are getting, just push it into the stack. So st dot push root. Okay, st dot push root, and then we will be going to the left part. So root is equal to root dot left. So here we will not be using the recursion, we will be doing with the help of a just iterative approach we will be using. And we'll also check if it's root it's not equal to null, then only it is going to push the value to the root, to the stack, and it will be calling to the left part of the array. Okay, then else if it is a null. Okay, then what we have to do, if it's returning like a null, root is null, then we have to check if my stack is empty, like this condition. If my stack is empty and my root is also empty, so if my is if my stack is empty, then we have to break the loop. Okay, break the loop, we don't have to continue. So root is over, sorry, left part is over, we have called the left part. Then for the root part we will be pushing an element to this list. So list dot add. Now what value will be adding will be the root. Will store root, and we will be storing the pop element. st dot pop element will be storing in a root, and we will be returning like storing like a root dot value. Okay, root dot value will be storing, and then we will be calling root is equal to, and then we will calling the root dot right part. Root dot right part will be calling. Okay, now I think it's correct. Okay, yeah, it's correct. Submit. Now why we are like doing this in this program, just basically what as a whole what the while function is doing, it is like going first inside the loop. If my root is not null, then we are just continue pushing the values. Okay, like first one will get pushed into the stack, then it will go to the root dot left part. Root dot left part, it's null. Okay, so it will first it will be called again, root dot left, it will be initialized to null, then it will go back to the while. uh, yeah, it will be checked, yeah, it's true, then it will again check if root is not equal to null. So this time it will be sending the control to the else part because root is null. because my root will be shifted to the left part of this tree. So it will come like if my stack is empty, so it's not empty, we have already pushed 1 to it. So we'll be coming to root is equal to st dot pop, so we'll pop the first element out of it, and we'll be going to list dot add the value 1. So next we'll be moving to root dot right part. So root dot right part, since my root is currently 1, so it will now be moving to root dot right part to this 2 node. Then again from here, again this function will be checked from while it's true, so it will be moved into the if. Now the first condition is false, since 2 is not equal to null. So again it will continue to push 2 in onto the stack, and then it will be calling to the left part of it. Then it will be initialized to the root dot left part. Left part will again be called and pushed into the stack. Then it will be again going to the left part of this 3. Then again the same story will begin from here, like it will be again checked, and it will be coming to this null. It will be again showing like a stack is not empty. Then it will again pop the 3 element from this stack, and then it will add it to my list part. Then it will be going to the right part of my root will be 3 at that time. It will be going to the right part of the loop 3, and then it will be checking like if yes it's null, so it will be coming to the else part. Then again it will be checking if it's my stack is empty. So that this time also my stack is not empty, since we have processed the element 1 and 3. 2 is already there into the stack. So now this time 2 will be taken up, and it will be pushed out of the stack, and then it root dot value will be stored into the list, and then it will go to the right part of the 2. It's again null. Then again it will be going for checking if my root is null. So again it will be coming to the else part. Now if my stack is empty, yes, my stack is empty, since we have already processed all the 3 elements. So this time it will be break out of this while loop. So the control will come out of this while loop, and it will return the list part of the data structure that we have stored the value, and the order in which we have stored is like the order in which we have processed the elements. Okay, so 1 3 and then 2, so it the same order 1 3 and 2 will be returned to it. And yeah, we have already seen that the program was running correctly. So coming to the time complexity and space complexity of this program, you can see like we are using a stack that space will be equal to the order of n times that the number of nodes is there, where n is the number of nodes. So my space complexity will be order of n, and time complexity is also order of n. We are visiting each node at least 1 times, and we are processing it. So yeah, order of n we can say, where n is the number of nodes present in the tree. We are traversing. Okay, okay. Thank you for this. Now we'll end this video here itself. Meet you in my next video with some other problem. Till then, do subscribe the channel, and do check out the other videos that has already been uploaded.